Okay, this video is going to be on mechanical advantage, and it should help you with some of the worksheet problems. Let's see, let's just start out with a simple little definition of what is mechanical advantage. There's sort of two ways that you can define it. One is by forces that you're using, so it's how much force you get out divided by how much force you put in to a machine, and that's going to be equal to the same thing in reverse, how much distance goes in versus how much distance goes out. So let's start with a little pulley system as an example, just so we can see what's happening. Let's say I just have a pulley system like this, and here I'm hanging some sort of weight off of it, and we've got some kind of strings hanging from there to there like that. And this is, of course, hooked up to something, and that's hooked up to something, right? Well, what I want to do is I want to actually have an input force over here. So I'm going to input a force over there. That's my force in. My force out is what's going to be coming over there. That's my F out, which is going to also be equal to how much this thing weighs right there. So whatever the weight of that thing is in newtons, that weight is going to be equal to that force out. Now distance-wise, the distance in is how far do I pull on the rope over here? Distance in. And then the distance out is how far up does the weight move? D out. Now it doesn't really matter what your setup is if it's a lever, if it's a pulley system, if it's some sort of other simple machine. The basic principles are the same. Now where does this whole equation come from? Where it really comes from is work. How much work I put into a machine has to be equal to the work that I get out, because work is the same thing as energy. Work is change in energy. So if I break down work, work is force times distance. Force times distance. Well, that's force in times distance in is force out times distance out. So when you have a simple machine like this, you can't actually increase the amount of energy. All you can do is play around with how much force you put in compared to how much distance you put in. The idea being that you want to have the force that you put in go down so that the distance that you put in has to go up. Why do you want your force to go down? Well, you want it to be easier to lift something, right? So that's how this whole thing is going to work, by just using that. So let's extend this, and let's just do a quick little example, right? I'm going to do a different example using a lever, because it's a little easier to see. And here's my lever, just like that. All right? I'm going to put something heavy over here. Let's say that it is, I don't know, 100 kilograms. That's its mass. If I figure out the weight of it, that's 1,000 newtons in weight, right? Which, it's not super heavy, that's 220 pounds, but you wouldn't really be able to very easily lift this. So if I use this lever, I can more easily lift it. How do I do that? Well, if I look at the distance in versus the distance out, the distance in is going to be over here, D in. I'm going to push down the lever really far on this side. When the lever lifts, it's going to lift this thing up over there. That's going to be my D out. So you can see that the D in is bigger than the D out, which is going to give me a positive value, a value greater than 1 for my mechanical advantage. There's mechanical advantage over there. So looking at this, distance in versus distance out, right? If my distance in is bigger than my distance out, then my mechanical advantage is going to be bigger than 1, and it's going to be easier. Easier how? Well, that's going to mean that my force out is going to be bigger than my force in. So I'm going to get more output force for how much input force I put in. That's the whole idea behind a machine, simple machine. So let's put some numbers here that I'm just going to make up. Easy numbers. Let's say that I have to move the lever 50 centimeters and I only lift the block 10 centimeters on that side. That's a ratio of 5 to 1. That's going to be my mechanical advantage. Let's go ahead and write that out. What's the mechanical advantage? Oops, hold on a sec. Go back over there. What's the mechanical advantage? MA. Well, that's going to be my distance in divided by my distance out, which is 50 centimeters divided by 10 centimeters, 5. No units on mechanical advantage, right? Because the centimeters cancels with the centimeters. So there's no units, it's just a mechanical advantage of 5. What that means is that it's 5 times easier to lift it. So if over here, if I have 1,000 newtons on this side, how much force input do I need to put on this side? F in. Well, your intuition tells you, hey, well, it's 5 times as easier. It should be only 200 newtons on this side. Well, yeah, it's going to work out that way. How do the equations tell us this? Well, there's a couple ways we can do it. Let's move that down a little bit. One way we can look at it is just by using the mechanical advantage equation again, the other way. MA mechanical advantage is force out over force in. We know that it's 5. We know that my output force is 1,000 newtons divided by my input force. It's got to be 5. That's going to tell me that my force in is 2,000 newtons. Right? That's pretty easy. What's the other way you could do it? Well, you could do this without even actually having figured out the mechanical advantage. You could just go back to our work in equals work out. Or force in times distance in equals force out times distance out. Right? So that's how it works out. Those are easy problems, and they'll all sort of be the same way there. Now, what else can we do here? One other thing we can do is we can talk about efficiency, because sometimes, actually, the amount of work you get out is not the same as the amount you put in. Efficiency, right? That is, how much work out do you get divided by the work in? Well, in an ideal situation, you would get the exact same work out as you'd get work in. So that would be the same as that, and you'd get a number of 1 for your efficiency, or 100%. In real life, you're actually going to lose some work. You're going to lose some energy due to friction. You always lose energy due to friction, somehow, somewhere. In your pulley, in your lever, in your machine, something's going to get lost to friction. Well, what does this mean? This is always going to be some sort of number between 0 and 1, and between 0 and 1. So your efficiency can be, say, like 0.8, for example. That means you're only getting 80% of the work out that you put in. All right, well, how do we deal with that? Well, if you got to be given the efficiency or figure out the efficiency. Let's do a problem where you have to figure out what the efficiency is. Okay? So let's say you've got another pulley system over here, right? And I'll just make up some numbers. There's the weight that you're lifting. Here's the strings on your pulley system. Oops. That was totally wrong, but you shouldn't have a little cross in there, but I had to get this cord over here, so sorry about that. Let's say that this thing here has a weight of 400 newtons, and you're going to lift this thing up by a distance of 20 centimeters. Once again, I'm just making up numbers here. Let's say that over here, you're going to pull this string a distance of 80 centimeters. All right? And let's say that the efficiency is 0.8. I want to know, what does my force in have to be? So how does that work? What does my force in have to be if my efficiency is only 80%? Okay, well, let's set this up by using our work equation and noting that the work in is not going to be equal to the work out. Actually, let me back up just a little bit over here. If I come from this equation right here, right there, and I rearrange that a little bit, I'm going to get my work out is only going to be 0.8 times my work in. All right, so let's just go straight from there and write this out. How are we going to do this? Work out. Well, that's force out times distance out is 0.8 times force in times distance in. I guess I'll put an X for times. Okay, so let's just start plugging in numbers then, and we'll figure out, once again, we're looking for what's the force in. That's the thing we don't know. We know the force out is 400 newtons. The distance in is 20 centimeters equals 0.8. The force in is what we don't know, F in, and the distance in is 80 centimeters. Now before we solve this, let's just reason with ourselves, what would it have been if we had 100% efficiency? Right? Well, look at this. 20 centimeters out, 80 centimeters in. That's a mechanical advantage of 4. You can just read it right off like that. So if my mechanical advantage is 4, and I look at this 400 newtons, I was hopefully expecting my input force to be only 100 newtons, right? Because that's 4 times less than that. Well, let's go and solve our equation over on this side now. Okay, 400 times 20, that's 8,000 equals 0. Actually, let me multiply 0.8 times 80. Let's get this going. So if I get that, 0.8 times 80 is, let's see, 64 times my force in. All right, so my force in, and just doing this on the calculator just to make sure, you know that it's going to be, well, hopefully you can see what it's going to be, but okay, 125 newtons. So that's more force. Yeah, more force as compared to that. Why? Because my efficiency wasn't 100%. So that's how you do efficiency problems. So go look back over this video, see what it is that you understand and what you don't understand. These problems are actually pretty simple. They really can start out from this equation up here, and either of these equations, meaning this one right here, or this big one to start out up here. And you don't really even have to understand the configurations of the pulley systems. How does this work? What's going on here? Doesn't even really matter. One thing to pay attention to on the levers is which side is the distance in and the force in. Generally, the force and the distance in are going to be on the side with a longer lever, and the output's going to be on the shorter side. That's usually the way it goes if you want to make it easier. Sometimes you see levers that are the other way, which it actually makes it harder to lift, but you get more distance out of it. And hopefully those problems will help you out with the worksheets too.